Hi there. Recently, I started learning C++, and I decided to implement a basic linked list data structure. So this is the linked list class here. We have a toString method, an add method, a remove_at method, and an indexing operator. And this is how you use it. You instantiate the list, you add on a few items, in my case, integers specifically, and you can print out the resulting list. You can get the item in the list at index 2. You can remove the item at index 1, and then do the same again with the updated list. So let's take a look. I'm going to build this, and let's see what we get. And we get what we expect. 3, 4, 7, 2, and then the one at index 2 is 7. And then we remove the one at index 1, which is 4, so we no longer have 4 here. And now the one at index 2 is 2. Great, let's see how that works. So the linked list is essentially a list of linked list nodes. So here I have another class, linked list node, and each of these nodes contains a value, so that would be the integer, like 3, 4, 7, 2, but also a pointer to the previous node and a pointer to the next node. Like that, I know where to go to get to the next item or the previous item. And what happens is, as we instantiate the linked list here, we go to the constructor, which is here, and we initialize these pointers first and last. So this is the first node on the list, and this is the last node on the list. And we set them to null pointers because we don't have any items to begin with. And we set the size to 0. And what happens is when we add a value, so when I go list.add3, we go here, value is 3, so we allocate on the heap a new instance of the node. And the reason we do it on the heap is that otherwise the object would get destroyed as we go out of this scope. As soon as we leave the add function, we would no longer have access to this to the value we just added. So that's why I put it on the heap, and we get a pointer. And so if there's no elements yet on the list, then we set the first, which is a member variable and pointer. We set that first to the new node pointer. And otherwise, so in the majority of cases, we're gonna set the previous of new node to be the last, which is again the member variable. And the last, we're going to set its next to the new node. And then we're going to update the last to be the new node that we just created. And finally, add 1 to the size of the list. And that's how adding an item works. And when we remove an item, so list.remove_at1, for example, it takes the index, and in this case, 1. So we keep track of the current node. So we start off with the first, and so this would be a pointer, because first is also a pointer. And we cycle through by doing current equals current arrow next as many times as index. So when we reach this point, we're targeting the correct node. And then we do a few edge cases here just to check if we're on the very first node or the very last of the list. There's some edge cases going on. But in the majority of cases, we're updating the surrounding nodes of the node that is supposed to be removed. So, and importantly, we're then deleting the node because it was allocated on the heap with the new keyword. So we need to explicitly delete it, and then we remove 1 from the size. and that's how it works. And the operator that can index it is also cycling through index times, and we just return the value at the current node. So let's have a look at the memory usage of this program if I start creating an infinite loop. So let's do while true, and we're going to do list dot add, and I'm going to add, for example, value 5, and just after list dot remove at, for example, 0, index 0. And so we would expect, because we're adding and subsequently removing, that it should keep the same size and memory space. So let's rebuild this and take a look. So this is running. Now let's take a look at the task manager and look at the memory usage. And indeed, we see that it's not increasing or decreasing, it's staying level. So now let's terminate the program. Now let's or rather comment this delete line, and let's see what happens. So just this line gets commented. We'll rebuild this. Let's see. Okay, it succeeded. So let's relaunch the application. And now let's look at the memory usage. And we can see that it's going sky high really quickly. So I'm going to stop it before it gets too crazy. And that's insane. Just because we forgot to delete the node, every time we thought we were removing it, but the object itself was still in existence if we didn't delete it. So that's why it's really important to delete it. So I thought that was a nice little practical application for starting to learn C++. And I didn't get to this point immediately at all. I had to kind of figure some stuff out before I got things to work, but I'm quite happy with this. And the coding style is probably awful. Like everything is public. Um, it's I'm not using very traditional ways, I think, of for example, setting default values for the constructor and things like this. But um, I learned quite a lot with this. I got the hang of using pointers now with the arrow operator. And so, yeah, I hope you liked this video and learned something, and hope to see you next time. Thank you.